Hello, I'm Pat Muchmore, and as I am standing here recording this, we are one day away from Innova Records' release of my new album, Babel Fragments. I'm incredibly excited about this, and I wanted to make one last video for you explaining some of the crazy-ass titles on the record. I'm going to explain the first and the third one this time, as you should already be an expert in the second and the fourth. After watching all three videos, you will have a PhD in the utterly useless field of Pat Muchmore's stupid titleology. Let's go to the videotape. The third piece on the record has the most straightforward title. It's this one here. I just pronounce it FR.2.A through K. And I think I maybe even mentioned on the first video I made that pieces that are named with this format are part of what I call my Fragment series. I should go into a little bit more detail about what the Fragment series actually is. These are a series of pieces that are themselves made up of a bunch of, fragment pieces that were written almost always in one sitting. So I tend to think of them almost as the musical equivalent of short stories, as opposed to the novelettes or novels of the larger pieces. This particular piece has 11 movements in it, and the title just breaks down like this. The FR part is calling it a fragment piece. That's always there. Then there's a Roman numeral saying which collection it is. This is the second collection of fragment pieces I ever wrote. And then finally, there will be some lowercase letters. In this case, it's A through K. It could have been A through some other letter. It just depends on how many fragments that particular collection contains. This one has 11, which for no reason I'm aware of tends to be a common number. If we open up the CD cover and look to the track listing for FR.2.A through K, you can see the 11 fragment pieces, the 11 short stories that I wrote. Each one's named by a lowercase letter, and then the place that I wrote it and the time that it was written. Some of these times are when I just came up with the most important idea of the piece, a major sketch of it. Others are literally when I put down the pen and I was more or less completely done with the piece. This particular fragment collection was written for solo cello, just me playing on my cello. But I wanted to explore something a little bit less familiar, so I chose to detune my cello from the standard tuning. Normally you tune a cello A, D, G, C. That's from top to bottom in a collection of 3 perfect fifths, we call them. I decided to try tuning down the top string and tuning up the bottom string. So instead of A, D, G, C, my cello for these pieces is tuned A flat, D, G, C sharp. In other words, I took 2 of the perfect fifths and turned them into tritones, the devil's interval. I call it my double Satan tuning. So there's really not a lot of complexity here as far as the title is concerned. That's it. Up here in the first piece, we'll have a more complex title to talk about. But before we go there, why don't I just play you a sample from this piece. Here's the score for the eighth movement. That makes it what the, my math is bad, 9th movement of this particular collection. This piece is, I think, the shortest piece on the entire record, and it was written in a van when the new music group that I play with, called Antisocial Music, was returning from a tour to Detroit and headed back to New York City. Nothing was particularly going on. Lots of people were getting a bit of a nap in, so I pulled out my notebook and started writing this piece. Got car sick almost immediately, and that might explain why it's as brief and discombobulating as it is. You'll notice there's color in this particular score. That's true on all 11 pieces in this collection. It's hard to explain to anyone who's not a string player, but there's a lot of difficulties involved with reading music when the instrument has been tuned differently than its normal form. If I were to write the notes exactly as they sound, then all the time my eyes would feel like they were lying to my fingers. My fingers would see E, and so they'd play an E, and it was supposed to sound like an E, not be an E. I don't know if this makes any sense. The point is, it's often helpful to notate in some way first just the where your fingers go on the instrument version, which is this larger version that includes colors in this score. And sometimes, as I did here, you might also notate the sounding pitches, which I've done in smaller notes up here, just so you can check yourself. But when I perform it, at least, I'm only looking at this color line. As far as I know, the color thing is my own invention. I'm sure somebody else has come up with it at some point. But basically, red notes are notes that are played on the bottom string, which means they sound a half step higher than they look. And the green notes are the notes that are played on the top string, the A flat string, and so they sound a half step lower than what they look like. It makes it much, much, much easier to perform. So here is the 9th fragment from FR.2.A through K. The only piece I haven't talked about in these videos is now the first piece here. The title's not as complicated as Babel Maya or Sheshach Maya, but it does have some weird bits. Let's get the easy things out of the way first. FR.1.A through K obviously means this is a fragment piece, just like the third piece. Its only difference is this Roman numeral 1, because this is the first collection of those sorts of fragments I wrote. A through K tells us that this too has 11 movements, although that's a coincidence. If we open up the CD, we can see the 11 movements here. The titles are a little bit more complicated this time around, mostly because, as you can see when you look at the places they were written, a large number of the pieces weren't written in America. And I tried, as best I could, to emulate the way whatever country I was in writes a date when I wrote the time of completion. So, for example, you may notice there's this kind of what looks to us kind of strange Roman numeral in the midst of this date here. That's because that particular piece was written in Budapest, and in Hungary they use Roman numerals very often to indicate the month instead of just a name. Also, you'll notice that each individual movement, or at least some of the individual movements, have their own complexities. There's some Arabic here, a kind of weird-looking shorthand, a particularly crazy-looking title here. All of that is a reflection of the fact that this piece, much like both Babel Maya and Sheshach Maya, is a member of my F of F of X series. Specifically, it's the fourth one that I wrote in that series, and that means it contains a bunch of little pieces. I've already talked about a lot of those details. The only thing that is completely unfamiliar on this record is this part, KR5S1 18D1. To understand this, you have to go back to your high school chemistry. For me, I actually go back even a little further. It was sometime in elementary school that I have no idea why, but I started becoming fascinated by atomic physics and subatomic particles, and I would have fallen into a wiki hole on it, but Wikipedia didn't exist in the 80s, so instead I had to fall into a Britannica hole, going through all the different particles that I could read about. I couldn't possibly have understood more than one word out of 20, but for whatever reason it was fascinating to me. At that time, although physicists were well aware it was not a particularly accurate model, the Bohr model was still being taught to us. This is the model of an atom where electrons orbit almost like planets around the sun of the nucleus, made out of protons and neutrons. Now, this isn't a horrible thing. This is a very valuable simplification of the issue, and most of the math and the understanding of how electrons work can be perfectly well codified in this sort of planetary model like this. Just replace gravity with electrostatic forces, and you've got an atom. But, of course, that classical physics version of things is, we now know, not accurate. It's a much more quantum and complex situation. Probabilities of location and such. First off, I'm not the person who should try to teach you about these things, and even if I were, this video is not the place for it. But you may remember learning about atomic orbitals at some point in high school chemistry class. Here's actually a pretty great illustration well down the page on Wikipedia for atomic orbital that shows visualizations of the probability areas of the various orbitals that exist. For instance, remember, maybe there were s orbitals, p orbitals, d orbitals, f orbitals. There are orbitals actually that use even more letters after that, but those are by far the most common. And they each have their own characteristic shapes. S orbitals are basically just spheres. These p orbitals are kind of like dumbbells, and then I start running out of good terms to describe what these things are, but they're gorgeous. And these red and blue chunks are just showing higher and lower probability areas in which electrons tend to be found in an atom. Again, I'm not the one to explain why that happens or what it means, but that's all you need to know to understand the title. You may remember talking about electron configurations in high school. For instance, if you're looking at a standard oxygen atom, then the electrons would be laid out like this. This 1s2, 2s2, 2p4 is just an indication of where the eight electrons of an oxygen atom tend to be located. Two of them are in the first s orbital, two are in the second s orbital, and the last four are in the second p orbital. There's a particular shorthand that physicists will often use if they need to talk about electron configurations. They'll go to the earliest noble gas that has a complete electron configuration in the name, and instead of writing out all possible electrons, they'll just put in brackets the name of the closest noble gas, and then just label the outer electrons. That probably didn't make a lot of sense, but let's look at an example. If I wanted to write oxygen in a slightly shorter way, I could take note of the fact that 1s2, this part of it, is basically just a helium electron configuration. That's the closest noble gas below oxygen. And I could replace 1s2 with the symbol for helium in brackets. That actually didn't help us at all. That made it actually, I think, a little bit longer. It looks a little bit cooler, which is maybe enough reason for me to like it, but not so helpful when it comes to oxygen. However, when it comes to an atom like strontium, it can get quite useful indeed. In fact, the name of this piece, Kr5s118d1. This is a very special kind of strontium atom, or rather a strontium atom in a very special shape, a very special form. Anyway, here's my strontium atom. I could recognize that 1s2 is basically just helium, and so replace it there. That doesn't help us a lot. But that's not the closest noble gas below strontium. There's also neon, which takes care of shortening even more of it. But that's still not the closest. There's also argon, which would make quite a bit shorter form. If it doesn't look shorter, that's just because I made my font bigger. But that's still not quite the closest noble gas beneath strontium. The closest is krypton, Kr5s2. Now, you may have noticed that that's still not the title. Instead of Kr5s2, I have Kr5s118d1. In other words, what should be two electrons in the fifth s have been split up, and one of the electrons has been put out in what is a very, very energetic orbital. I think I picked this more or less randomly, but the 18d orbital is a vastly far out orbital indeed. This atom would still be strontium, but it's what's known as a Rydberg atom. The atom has been put into a Rydberg state, which means its outer electron has been excited into a much more energetic orbital. The physical manifestations of this are beyond my understanding, and again, beyond the nature of this video, but what's interesting to me is these atoms that are in a Rydberg state tend to function oddly like the classical model that I was taught when I was in elementary school. That is to say, the outer electron does tend to kind of orbit the rest of the electron, sort of in the way the Bohr model taught us electrons should orbit the nucleus. In other words, it's sort of like classical physics kind of pulls itself out of quantum physics for a second, and I'm fascinated by that divide, that continuity between two seemingly opposite things. I was discussing this over beers once with a colleague of mine at Sarah Lawrence College, a physicist, and he was absolutely mystified as to why I was so fascinated by Rydberg atoms, and I explained briefly my fascination, and he said, okay, I get that. I guess it is hardly the most interesting example of the collision of classical and quantum physics, and he's right, but it's the first one I learned about, and it's still fascinating to me. Musically, this manifests itself in pieces that try to blur and move between what I consider quantum type sounds and what I consider classical type sounds. A quantum sound would maybe be having the musicians just play whatever they want in a tight cluster of pitches, or random rhythms but specified notes, or maybe glissandos up and down, things that have a continuum to them, things that are irregular and unpredictable. Classical things are going to be more point-like sounds, lots of pointillistic bits, or perhaps logical systems like tone rows, or more straightforward pitches coming out of the clusters of the quantum world. And what I'm really interested in is the space in between, the kind of liminal space where things are both indeterminate and odd, but yet somehow pointillistic and sharp. This kind of particle-wave duality in my own poetic musical kind of way. So let's listen to an example. Here is another score page. This is from this piece, the first piece on the record. This is the B movement, the second movement of the piece. And the score, I hope you can tell, is obviously inspired by that Bohr model of an atom. There's a tone row that goes around the, quote, electron orbit. There's a nucleus, quote unquote, in the middle. And then every once in a while, there are these explosions of notes out in these higher energy orbitals that get called for in various ways. The colors, by the way, indicate different things depending on which way you're reading the music. When you read it clockwise, the colors mean, as indicated here, purple notes have flats on them and orange notes have naturals on them. If you're reading this way, it's the opposite. Orange have flats, purple have naturals. It's all very, very complicated, and I am a bad person, but I'm not bad enough that I would make musicians try to actually read this. I made a performance score, and that's exclusively what we perform from. But this is actually how I conceived the piece and put the piece together, imagining this tone row, which I think I took from Webern, actually. I was in Vienna when I decided on the tone row, so I decided to use a Webern thing. And then figured out how I could make it into a circle that could be read both clockwise and counterclockwise, and put together this rather elaborate and deliberately obscure timeline. And this is theoretically where the musicians would figure out which way they're moving and what their dynamics are. Again, I wouldn't make any musician actually have to read this score, but I like it, and I think it's a nice visual manifestation of the central concerns of my Rydberg pieces. You'll hear glissandos grinding against an open string. That's a kind of quantum-y sort of sound to me. This is a tone row, but it's often presented in different or even random rhythms, which gives a sort of a probabilistic, unpredictable quality every once in a while. I don't know, I've talked about it enough. Let's listen to this movement. And so there you have it. I hope you found something at least a little bit interesting in one of these videos. I also hope that if it's Thursday, July 28th, or Friday, July 29th in the year of our Lord 2016, that you'll consider donating to my Indiegogo campaign, the link for which should be appearing now. If not, I understand, and I hope that you'll just consider purchasing my CD. It'll be out on the Innova Records website starting Friday, July 29th, 2016, and all the usual places, Amazon, iTunes. Buy my CD, buy my CD, buy my CD. I'll leave you with one more example from the album. This is one of the quieter tunes off of the first piece, KR5S1 18D1 FR.1.A through K. And this is one of the movements that's written for all three string instruments to have one string detuned, and it gave us a chance to explore some interesting harmonic combinations. I hope you enjoy it, and have a great, great life.